This is a short video that shows something I think is really interesting. I have modified the Engage A-scope application to add two new features. The first is the ability to see the missile altitude versus range on the same graph as jammer power in the seeker. And the second is to allow altitude noise on the missile flight profile so the missile can float up and down during its inbound path. So if I click this checkbox here, we can now see the altitude versus range, a stepwise descending sea skimmer missile. And if I add altitude noise, then we get the expected, floating up and down thing. So let me take the altitude noise off and deselect the auto range. So now we have a constant missile altitude. It's just simpler to understand what's going on. Now as I float the missile up and down, we can see how the nulls and peaks shift in and out in range as the altitude is changed. So let's add the altitude noise back in, and here we get the expected fluctuations, which look surprisingly like a real missile flight in an air carry situation. Each time I click the recalculate button, we get a different flight profile. So, there's one. Now watch what happens if I'm going to deselect randomize there. If I now float the missile up and down, how interesting is that? Look at these gross features traveling through at a longer range. We see the nulls, which are there in the non-noise case, are really underlying or overlying, or whatever you want to say, the altitude noise. And this is exactly what we see in air carry trials. These are trials results that kind of look like the theory predicts, but not exactly. And sometimes just can't quite put my finger on why they don't match up. But if we take the noise away, we see, and we fiddle to the altitude a little bit, we see these nulls traveling in and out, put the noise back on, that's exactly the same noise that we were just looking at. You see the same nulls, these are the nulls, this is what's actually happening. So this gives me confidence that we do know what's actually happening. The propagation model is correct for air carry trials, even though the results only sort of look like they should. That's what's going on. There's nothing wrong with the model. We just have to configure it correctly. And this concludes this short video.